Thank you so much, everyone, for joining us today. We really appreciate you taking time out of your busy schedule to learn a little bit more about our traffic link solution. And specifically, the topic here today is how we're using detection to solve mobility and congestion challenges. We have a great lineup for you today. I'm super excited to bring you this content. So I just want to start with a very quick overview of our technology and how we think of our solution. Um, we call ourselves often the smartphone with intersection. And what that really means to us is we supply a combination of hardware and software that allows traffic teams to achieve their strategic goals. And, just like at one point you used to have to buy a calendar, you used to have to buy a phone, you have to buy a Rolodex, and you had all these different pieces of niche or direct functionality that would be on something like your desk. Um, and what we saw in the smartphone era is a lot of these technologies collapsing into software. So rather than having to buy all those or maintain all those different discrete pieces, you now just have a phone, you have a piece of hardware, and your calendar and your notepad and your contacts, those are all just simply software applications that exist on your common hardware. And we're really trying to bring this approach to the intersection and to traffic. So we deploy a common set of hardware to the intersections, and everything that we do is simply software running on top of that common platform at the intersection. And we think that adds a lot of power and flexibility and extensibility to the traffic system and to obviously your intersection. So this is our smartphone. These are the three hardware components. We have a SmartLink, the SmartSense, and the SmartView 360. At a super high level, our SmartLink is essentially our connectivity and communications device. It's what provides connectivity to our cloud. It's what provides communications to the traffic cabinet over 4G or LTE. It's also a switch, and it really can do a lot in terms of pulling all sorts of telemetry and phasing data back from the intersection that you can use both in terms of optimization and for operational use cases. And I think Brent and Chris are both going to talk about some of those. We then have our Smart Sense. Our Smart Sense is essentially what does detection and counts. It's our roadside edge processor. This is where we do all of our machine learning and artificial intelligence and that processing directly at the side of the road. And it's what fuels our accuracy and our extremely high standard of quality when it comes to vehicle detection and turning movement count data and continuous count data. We pair that up with our SmartView 360. That's our 4K 363-degree camera, single point camera that covers an entire intersection. And with that one camera, that's where you can do both the remote monitoring, so use that connectivity to tap into that camera remotely and stream video. But it's also the camera that supplies the video input for our detection and our counts. We pair that up with a web portal. That would be your operating system layer. We call it Traffic Link. And Traffic Link is the software layer in which you interact with our solutions and solve problems. So again, everything that we do in terms of software uses the same common hardware. And once you have this installed inside your intersection, everything else just becomes simple software applications. So these are our software applications or the kind of problems that we solve with software. Today we're going to talk, kind of across a whole bunch of these because really it takes a whole bunch of tools to solve these more complex problems in a city. So although the basis of these is video detection, and video detection plays a very key input to the data that goes into making changes and solving problems, we're going to see aspects of signal maintenance and operations, of traffic insights and using analytics. And then we do have both safety analytics, which is red light running reports, pedestrian compliance reports, and a combination of continuous count data, and that's 24/7 multimodal turning movement counts. We're not going to cover those topics so much today as we will the first three, but just so you're aware, these are all problems that we solve with the one piece of hardware and with a common platform. So that's a little bit about our system. The high-level architecture, I know that most technical people really want to see this, which is our SmartLink and SmartSense, those two pieces, the connectivity and the compute, both install inside the traffic cabinet into your traffic controller. That would then provide LTE cellular connectivity up to our VPN and to our cloud. We do have alternative deployment options. So if you have a private cloud or if you have fiber or something already existing at the intersection, we can leverage that. And that, of course, goes out to then our portal, but also to third-party software and other systems. So today we're going to talk a little about adaptive and our integration there. So all of that is via APIs, both locally at the traffic cabinet and in the cloud. Then, of course, out from the cabinet, we get to the SmartView 360 camera. And if you weren't part of our first webinar on this topic where we talked about deployment options and camera heights and what that looks like, feel free to either reach out and we can answer those questions that are a little bit more technical and about deployment, or feel free to go back and watch that previous webinar where we talked more about the architecture, deployments, and what this looks like in the field. So our goal here today is really to share 3 smart city stories from the field about how something like detection or connectivity and some of those technologies really helps us to achieve outcomes. And we'll talk about what different outcomes we got to, because I think these 3 stories have very different outcomes, but they're all built on kind of common principles, common technologies, and kind of all have either connectivity or detection and data at really the center of them. So I'm really excited today to start with Quincy. Chris, maybe I'll let you kind of give another quick overview of kind of how you got started working with Miovision, and then we'll kind of move into your content around the projects that you've been working on.
Great. So like I said, I started my position about 3 years ago and was given sort of a broad charter by the city council to fix traffic. And you can sort of see me doing, I had my video on, the air quotes. Obviously, that's a very difficult thing to do. It's something that everybody in theory wants to have happen. And what, we had to set forth on a particular path in order to make some headway on that. The interesting position that we found ourselves in was that a lot of the investments that had been made in the city were sort of spotty. It would be an intersection upgrade here or there. There was nothing really ever done cohesively across a network of places to say we're going to upgrade all these things all at once. We're going to have a central ability to control and observe. So we started in a position, oddly enough, not having made those investments in the past, I think allowed us to jump right into the deep end of the pool with the most modern cutting edge technologies that were out there that really are built toward that system-wide type application. Instead of everything being a closed loop type system or very local to a particular intersection or a couple of intersections, we were able to really say, look, we want to do this across an entire network. So what we set forward to do was to do an adaptive deployment at 20 intersections, give or take, in our downtown area, a very busy area with a lot of commercial activity. And if you'll see on the center, on the right-hand side of the screen, roughly in the middle of it, that's Quincy Center. The area is pretty dense. There's a lot of traffic. There's a lot of businesses. There's schools in the area. There's residences in the area. So it handles a lot of destination type traffic and a lot of through traffic. And we're only a hop, skip, and a jump from downtown Boston. So we deal with a lot of regional traffic as well. What we found in order to make the adaptive platform work was that our existing detection was inadequate, and certainly our existing communications were totally inadequate or non-existent. So we worked very closely with Ocean State Signal, which is our a vendor of traffic equipment, who has a relationship with Miovision out of Rhode Island, and they were a respondent to our RFQ to deploy an adaptive system here in Quincy. What we liked about the proposal was this tremendous level of integration between the adaptive system, which we selected as SureTrack, but also all the other things that you could do with something like this. And I think what was kind of interesting for us was that as you make a system smarter, to some extent you sort of expand the footprint of things that can go wrong. As you have more connectivity, you have more opportunity for that connectivity, or perhaps for the detection, or perhaps for any of it to sort of tell you that something is not quite right with the system. And with an adaptive system that's relying on predictive analytics, if you have bad data going into the network, you're obviously going to have bad performance coming out on the other end. And any number of things can happen to make that so. So what we have found, with our deployment of SureTrack with the deployment of Miovision cameras across this whole network, and it's, now almost 40 different locations where we either have cameras or we have the SmartSense technology alongside, is the ability to monitor the performance of all of our different upgrades. The SureTrack system, our emergency preemption platform, which through applied information, and just in general, what's going on out in the road has been incredibly, incredibly valuable. When you have an adaptive system, as I said, you sort of rely on that. You're not making individual tweaks to timings. You're not even adjusting how things are coordinated. You're allowing the system to do that itself. So in order for people who are working, as it is in our case, all over the country to try to make this system work, having something like Miovision certainly offers the eyes on the ground, but then it offers really this very robust statistical and analytical framework to tell us whether or not we're achieving the results that we hope to achieve. And then it very quickly guides your eyes toward how you can make things better. And I think what's great about it is that it gives you the tools to do that type of analysis. It makes, I think, people involved in the traffic deployment or in the deployment of all this technology, I think, a much more integrated stakeholder really in what's going on. And you might think that the opposite would be true when you go to an adaptive platform, but I think what we have found is that it has really helped us become even more involved and more sensitive toward how all of these different things work. Specifically, one thing I wanted to share, and I talked to the team at Miovision about this when we were prepping for the webinar. Emergency preemption, the technology that we have in the city, has really changed by leaps and bounds through our deployment of Applied Information's Glance suite. One of the things, though, that we seek to find, or that we're working to do better, is to understand, okay, how well is all this working? Because it's one thing to have a little bit of delay for people on their commute. It's another thing entirely to have a preemption system not perform well for your fire department, police department, ambulances, etc. And I think now more than ever, right? I mean, it's always been important, but certainly now I think the ability to respond to these sorts of emergencies. So we are able to pair together the Glance platform through Applied Information and know how the system's supposed to work, but really see how the system responded in this beautiful, easy to view format that you see in front of you right here. And this is on a daily basis. We can say this particular intersection was preempted at this particular time. It was preempted at this particular time. The call might have come in on phase 4. It was in 2 and 6. We saw how it very quickly, the minute the preemption call came in, got out of that particular phase and went directly into the preemption. It's incredibly helpful when dealing with folks at the fire department to say, guys, I saw that it worked beautifully, or conversely, I saw that it didn't work so well. And it gives us the ability very, very, very quickly and very clearly to understand how these things are working. So as Matt said, when you think about the smartphone or the intersection, we do view it very much that way, where if you made your home smarter and wanted to know how smart your home was, how well it was performing, you would really want to know wherever you are via that, that one platform, the smartphone, if you will. You'd want to have that information at your fingertips. In our case, the way we want to see this system performing, especially in the early days of COVID and everything else, the ability to not be in the office and to be able to instantly access all of these metrics was invaluable, really. We were able to seamlessly leave our office, as we all did on a Friday, and all of a sudden be remote on a Monday and really not feel like we missed a beat. So this platform, we've dealt with a lot of different vendors, we've dealt with a lot of different technology. This platform is just so adaptable to everything we're trying to do. And we, expanded from our initial deployment to a wide range of intersections in the city. And, certainly have no regrets, quite the opposite, just are very, very happy with what we did. And additionally, I think we look at the commitment that the Miovision team has to making, the background algorithms and everything else. As they make things better, we benefit from it. Initial deployments of video detection and so forth really couldn't say that. You bought something and that's it. It was deployed at the intersection. In this case, because it's cloud-based, because it's software-based, we feel very, very confident, and we know from experience that the folks at Miovision are going to make it better, and we will always benefit from the latest improvements that they make. So again, been very pleased with it. I think it's an essential upgrade as you go into adaptive technologies. And really, even if you don't, an essential upgrade to understand how well everything you have is functioning in a very, very easy to learn format. If you have a very geographically spread out city, the ability to be at a central location and observe all of this in real time is such a huge time saver. So it's an investment financially on the front end, but really the benefits that you realize from it are wonderful. And I don't know what anyone else's communities are like, but as our community gets ripped apart with gas work and all the other stuff that destroys loops, we have a level of continuity here that has been tremendously beneficial through how we're able to connect this. So I can't say enough good things about it, and I'll gladly turn the floor back over to the next speaker.
Thank you, Chris. Maybe I'll just ask you two quick questions, if that's okay. The first one would be, obviously your system here is leveraging cellular connectivity. How do you think about, when you think about connectivity, how do you weigh the options of, say, fiber versus cellular versus radios for your deployment?
Well, I think a lot of that would depend on how strong your relationship is from the traffic department with the IT department. And in our particular case in the city, it was a very strong connection. So, we have been able to do some of that leveraging to build out that backbone, the fiber backbone in the city. But, knowing that you can go out to an individual island, if you will, and get that connectivity is enormously important. So, it's such a nice turnkey solution. That's a huge benefit of it. But obviously, the compatibility with existing networks is great. And if you were to deploy a single Miovision product at an intersection or in a smaller community without a big, robust IT department, you could do that, and you wouldn't feel as though you were doing something that you couldn't handle. So, it's the kind of the adaptability of it is incredibly important.
Thank you. That's a great point. And then I guess my other question would be, you mentioned, kind of construction and loops getting tore up. Is there anything else, besides that you find valuable about doing detection via video versus loops or radios or another technology?
Well, like I said, I think one of the best things, so often you rely on, geez, I need someone to come out to my city to do something for me because, either we don't have the skill set internally or whatever the case may be, or you're not familiar with the area. Being able to do all of this work via video, especially with the wide footprint that the video detection gives you, I think is very important to allow people to understand, what is going on in addition to the detection at the intersection. The 360 view allows you to say, hey, that shopping center that's adjacent to this intersection. People are like, well, what are you talking about? You can see it on the 360 view. You can see it, and it's not just a point of reference on a map. It's something that you can actually see happen. An unsignalized driveway turning out onto a busy corridor. It's important how those things function, and sort of under any other scenario, anyone who's not physically there would really not have much of an idea how it operates. So I think the detection's fantastic, but then also that holistic picture it gives of a geographic area is invaluable as well.
Perfect. Thank you. And for those attending, if you want to put some questions for Chris into the chat, we'll come back around at the end and we'll get Chris maybe to answer some of your questions directly. So feel free to throw that in there. With that, I'm actually going to hand it over to Brett now. Brett, we'll take us through two other examples of kind of how other cities are using this technology to make a broader impact in their communities.
Great, thanks, Matt. So I want to talk about the first story as our friends at the town of Milton. Town of Milton, for those that don't know, is just it's a community outside of Toronto, about an hour away from Toronto in Ontario, Canada. It's actually one of the fastest growing communities in Canada. It's got the nice combination of low house pricing and proximity to major cities. With that in mind, it kind of comes with the challenges of growth. And so this is a heavily a commuter town that is along one of the busiest highways in Canada as well, the 401, with the growing population and growing signal set. So as it says here, they manage about 60 signals today and about 60 signals around in the surrounding region, in the Halton region here. But that's almost growing daily at this point. And when you have a community that is growing really quickly, that comes with common and unique challenges around all the different types of modes of transportation. And so what I want to get into is kind of how they approached us with the first problem that they had, and how they've applied our technology from video detection to then supply data from counts as well as performance measures, and combine the data sets together to see if they can help understand a specific problem that's occurring. So we started at these two locations. This is their kind of their downtown area where it wasn't really built as a commuter type road. Obviously, it's an area of little shops, and it's a more historic part of the town. It's been there the longest, but it wasn't built for capacity. And if you can tell on that map there, Martin Street is actually one of the roads out to the 401, out to the highway, which means this all of a sudden became a heavily congested area of commuters trying to get through the downtown area from some of the neighboring subdivisions and things like that. So they had an instantly poor mobility and increased traffic congestion that was almost changing by the day. And they needed to address this problem as fast as possible. And they tried traditional methods. They drove out there, they assessed the problems, they tried leveraging simulations and different ideas, but we still weren't getting to the heart of the problem and ultimately making this better. So we proposed installing the devices, and let's get to the heart of it with data. And so from there, we looked at the detection design, we looked at the performance measures, we looked at the signal operation and the overall volumes coming through here. And like many small, tight corridors, especially when signals are really, really tight together, coordination is incredibly important, and offsets are incredibly important, especially when you're within, call it a 500-foot range. And when you're in this type of range, that coordination was our first spot to look, because how well are these coordinated? And so we looked at the performance measures, looked at the phase interval, and as the first thing that stood out to us was actually the cycle lengths of the controllers. And we used the traffic link performance measures to analyze these phase interval charts that you see on the right. And the phase interval chart essentially is showing what is the length of the cycle, and you can see it's actually variable. So when we first plugged in, the cycle length was variable, and when you think about coordination, that just leads to many problems. And so as we dug in further, we looked into the signal operation, we looked into the counts and volumes, and realized that it was a ped push button, a high volume of pedestrians that were approaching this intersection from neighboring schools and like daycares and things like that were crossing the intersection here. And so we were able to assess that problem, make a change to the controllers that ultimately led to an improved cycle length, which was observed across not only the phase interval charts being consistent, but we started noticing things in the other metrics like occupancy ratio. So one of the main ones is a split failure, which I'll talk about in a second. But we were noticing originally a high volume of split failures, meaning the zones of detection were being occupied as soon as the light turned red. We saw an immediate reduction in those. But as we started looking at those detectors, we started trying to understand how they're operating and where zones were drawn. And so having a remote connected detection tool to not only look at the phasing intervals or even the overall operation, as like Chris was describing, actually looking at the detector design. Where are the detectors drawn? Where are we placing calls from? And how is that impacting the overall operation? And so optimizing the signal from a perspective of where is the call coming from allowed us to make optimizations to where we want the calls to come from. So basically, when we assumed where the zones were by drawing them at the stop bar, and we realized they were actually, the original loops were determined from about 3 car lengths back, it led to an optimization of how we impact when a car is detected, which then allowed us to correct a baseline data set of where and what volumes we were assuming approaching this intersection. This essentially led to a much better data-driven approach to understanding both the signal operation and the detector inputs. So we actually did write a nice case study about this. It's available on our website. There's a video about it that actually has Heidi from the town talking through her experience as well. It's a great video. I suggest you take a look at it when you get a chance. But as I mentioned, between the operation of the phase, so managing those PED push buttons that were causing a variable cycle length, as well as getting data from proper optimization, proper zones from the stop bar, we were able to instantly see a reduction in the split failures of 8.5%. That basically means we were 8.5% more successful of progressing cars through or servicing the demand that was waiting at individual approaches. Throughout all of that, it actually improved the overall travel time. So one of the tools that comes with our product is actually a travel time probe that goes on top of that goes with our antenna. And so immediately, not only did we see the progression look better in the metrics, the common constant cycle length, we also saw the overall travel time improve, which is usually how us as drivers actually feel the impact. It took me less time to get through this, which is me as a driver, that's the outcome I'm looking for. I want to save time. And so we saw an 10 to 18% improvement overall on the travel time. And then if you look at all of the individual approaches using those performance measures and charts, they were able to realize almost a 30% improved progression as well. So this was only in a matter of about 4 weeks, this amount of improvement was able to be realized and determined from the product. And now as the city as the town continues to evolve, more residents, more housing, they will be able to continue to adapt to the ever changing environment around them, and they have a platform now to work from. So it's been an amazing experience working with the town of Milton and watching their progression with our product. Cool. So the other story I want to kind of cover is our friends at the region of Waterloo. This is actually where Miovision's head office is. So this is where we work out of. So their region of Waterloo is a great partner of ours in helping us shape kind of the use cases, the value that they're getting out of our product. And we spend a lot of time working with them, and we're excited to continue that. So they came to us with another flavor of traffic problems that are both common and unique to some degree. But here in the region, they have recently installed and just launched a light rail system along the major corridor. The light rail system is about 19 kilometers with about 19 stations throughout the entire city. And then there's another planned approach to launch another stage of this down into a neighboring town of Cambridge right below it. And so when this was first installed, it was a lot of questions around how is it operating, how are individuals interacting with it, pedestrians, bikes, cars, buses, trucks. Everybody kind of converged in the same location, including trains. And since some parts of the rail were actually shared between the light rail system and freight trains, we also have the combination effect of who's on the train lines and how are they being managed through the intersections. So we started with a pilot to help derive that value and understand some of the initial challenges. We chose 4 locations along the route to help understand the impacts of the LRT operation, highlight the pedestrian behaviors, the delay, the safety aspects of this intersection, see how can we combine the detection zones with the phase information as well as preemption from the rail lines, and see what we can come up with between various versions of these intersections. So the one I want to get into will really cover We'll cover a combination of things, but this derives at not only traffic performance, so the impacts of coordination, the saturation, the delay, but really looks at the pedestrian impacts. So looking at their behavior, looking at the signal behavior in relation to the spatial behavior of the pedestrians, as well as the cyclists. And then ultimately, how are these LRT or LRV trains actually interacting with the signal and the pedestrians around them, leading to an understanding of how well or how safe is this intersection actually operating. And so we started with looking at the first intersection of Ottawa and Mill. And at this intersection, you can see it's a very complicated location. There's 3 rail lines. There's an offset through street between the 2 sides of Mill Street, as well as the major line of Ottawa, plus a couple of pedestrian crosswalks. So you can see how a lot of things converge into a single spot here. So at first we wanted to look at this movement that's highlighted. And so we drew detection zones to operate normally for actuation. We also are connected into the controller to understand the phasing and the preemption of the rail line. You can't quite tell in the picture there, but the one station, the Ottawa station, is actually right below this intersection. So the train stops kind of right at this intersection, and then they can turn on a preempt and then enter their way into the intersection towards it. But what we wanted to understand is how often is our cars in this right turn lane that's going to potentially collide with where the train or rail is going to be, and do the signals actually operate in a safe way, and evaluating the impacts of this, and essentially tracking those close calls that may be occurring. So you can kind of tell that we're headed towards the pseudo metrics of potential conflicts by leveraging not just computer vision, but leveraging the combination of the signal information, preemptions, as well as the detector tracks, including the pedestrian information. So we were able to analyze the before version, so as soon as the train went live, and how well is it operating. And then we were able to derive at a couple ideas and a couple fixes that the region here implemented. So here's a quick little video of just trying to highlight kind of what this looks like and what this would feel like to a car. And as a vehicle would enter this zone, you can see how the train would be progressing towards the intersection, but then there's vehicles also on the through line. And so this is when you're hopefully checking your blind spots and you're hoping the intersection is accounting for you. But luckily the train here actually recognized that there was a car approaching, and they both yielded to each other. And so we could see that there was a car and a train at the same spot at the same moment, which led us to count up how often was this happening. And we were able to start understanding essentially the frequency of this. And when we looked at the original frequency, we were seeing within about a month, about 50 occurrences of this actually happening. When we looked at the occurrences, 50 is quite a bit, or in the sense that it could lead to a potential problem. Not that there are problems that are happening, but those types of scenarios leave it up to drivers' decisions, and you want to create a scenario where the signal is actually managing it in a little bit safer way. And so this allowed us to drive at a simple concept of preemption, where when train preemption is on, don't allow this phase to actually progress. And so that actually limits the chances of it occurring. And so line up not only the phase management, but also an all red scenario where you just essentially limit the time. And we went from about 50 occurrences before in the before scenario down to about 10 to 15. The reason why we still see that there's a couple occurrences still occurring is mainly because of now looking at the performance measures. Now we can actually see more detector occupancy, more signal operations, and we're noticing that now there's a combination effect of phase and cycle lengths, where when you look at the overall performance measures, the amount of time that's available there for an intersection to cycle and clear out those movements before the train arrives is a little bit too short. So anyways, with that in mind though, still being able to reduce the potential chances of a collision down about 70% overall within a simple analysis of this intersection allowed everybody to sleep a little bit better at night, and implementing this resulted in a quick outcome for the region. And so we started taking the same approach across many intersections about how to address pedestrian behavior around an intersection through charts like pedestrian compliance. Are pedestrians in the zones when they're supposed to be? Are they crossing the roads when they should be? Are cars in the zones when they're supposed to be? how are they relating to movements around them. And so when you get the combination effect of really well-designed detector operations with signal operation as well as performance measures, you get a nice combination to be able to assess problems well beyond traditional studies. So it's been really exciting working with the region and seeing how they've been able to apply our technology in various different ways, and this one has been the most exciting.
And then now's a great time to kind of facilitate a little bit of a discussion. So we've got a nice 10 minutes left here. I would love if we could get some questions into the chat. I see we've got some already in there. So please, now's a great time. If you got questions for Brent or Chris or myself, please throw them in there now, and we're gonna get that conversation started. So Chris, maybe I'll start with you. I've got a question here. And the question is, what has Quincy learned so far about camera placement? What work has worked for you guys in terms of camera placement? What hasn't, and what do you look for when it comes to getting a good camera deployment?
So I think we've kind of done every conceivable combination of camera placement that you could have. So, generally speaking, over on a mast arm over the middle of an intersection is the way to go. The only caveat there would be to make sure that you have the ability to get the Cat5 cable from that location at the camera to the cabinet. There's any number of reasons why that might not be possible, but generally speaking, as long as the conduit runs okay, that's the best way to do it. If you're looking at an intersection that has, post-mounted heads and no mast arm, what we have done in those cases is installed a 20-foot pole and mounted the shepherd's hook on top of the 20-foot pole back toward the middle of the intersection. And that's given us the appropriate amount of height to do that. So it's not as if you need to install a mast arm to make this possible. And then on span wire locations, we have taken the shepherd's hook and put it perpendicular to the riser itself and put the camera back out over the intersection that way. You can certainly put it, rise it up vertically with it, but the perpendicular option is an application that we had to do in one particular case because we had an overpass to play with and so forth. You could also mount them to a utility pole if you're comfortable doing that. Whatever the relationships are with the utility, it's certainly doable. In that case, you would run the wire for the Cat5 cable overhead, which is something we've had to do a few times. So all of it is possible. None of it would be an obstacle to deploying it.
Great, thank you for that. I have another question here. Maybe this is for Brent. Brent, how far back can the virtual detectors be placed from an intersection?
Yep. So optimally, it is a little bit of a factor of camera height, but assuming you're, call it like 25 feet up, we're looking at about 150 feet to the stop bar. And then from the stop bar back, you can go 40, 50 feet. So we're looking for the stop bar range to be within about 150 feet. The higher the camera goes, the more that expands. So if you can get the camera to 30 feet, it gives you an effective range that's a little bit further back, and so on. There is a table on our help center that actually breaks down heights versus distance, and it also compares stop bar to the front of the zone to the back of the zone, so you can kind of map out an intersection. But often what we do with all of our customers and our partners is we offer our support in the sense that we can help you do an intersection assessment. If you have an intersection in mind that you want to deploy video detection to, that you want to get a lot of data and results out of, and you want to make sure you get your zone and placements rights, feel free to reach out to us. Our technical account managers will help do an intersection design with you and make sure we can get a camera to an optimal spot. So
I'd also add too, I think one thing that's great about it is that, there might be a situation where it needs to be exactly where you put it or else it's not going to work well. But in our experience anyway, there's a good amount of play, which I think also helps the installers do the work. So our city staff did all the installations. I think maybe the first one you might want to get some help with if your staff doesn't feel comfortable. But once they see it go up in the air, I think honestly, anyone who has a bucket truck and electrician with a little bit of experience, it's very, very doable, and it's only the single point. So it's really just a very advantageous thing to develop the capability internally.
Yeah, exactly. Great point. We've seen that happen a few times where contractors ask a couple questions about the first one, and then I've seen some of them roll through 20 plus after that all on their own, and they do an amazing job watching them work their way through. It's designed to be easy, and like you said, it's got a lot of play with it.
Thank you guys. I have another question here. I could take this one, which is how many approaches can one camera cover? It really comes down to size of intersection. So on the majority of intersections, we do require just one camera to kind of get all the approaches. Then depending if you do have a relatively large intersection or it's spaced out, like Brent was showing that relatively complex intersection with multiple rails and crossings. If it's large like that, then it may require two cameras, and we can support a two-camera deployment that works together both in terms of detection zones and counts. But the vast majority of intersections we can cover with one camera, given the appropriate height. Another question here I'm happy to take is, what is the accuracy of our turning movement counts? So on the vast majority of intersections, we are 90 to 95% accurate on our turning movement count data. And then, somewhere in the ballpark of 80 to 90% accurate for pedestrians and cyclists as well. So those counts are happening 24/7, 365 days a year. And again, that typically comes down to quality of deployment as well. Of course, it comes down to can you see the bike lane? Is it obfuscated by a pole or something like that? But certainly when we have a clear line of sight into the turning movement count overlay, we are, I would say, the quality of data that we produce in terms of accuracy is in that 90+% range. And that is, again, that's for counts. When it comes to purely vehicle detection, we do meet the turtle spec of being 99% plus accurate. So that's more about the turning movement count accuracy than it is about detection accuracy. I do have a question here from Eva. Thank you for joining. She's heads up the ITS standards for the American Society of Civil Engineers, and she's curious about what standards would be helpful for our technology devices. Eva, maybe I'll follow up with you offline. I don't know if we've got the appropriate people to have that conversation with you right now, but I just want to let you know I saw that question, and I'll for sure follow up with you on that. Here's another question, maybe for you, Brent. Is the camera pan, tilt, zoom? If the tech moves to monitor traffic, will it revert back to its default position for counts? So feel free to answer that one, and I can assist if there's something you want me to cover there as well.
Sure. Yeah, so we have a fixed 360 camera, so there's no physical components that move in our camera. Less moving parts means longer life of camera. But what we've done is applied a virtual pan, tilt, and zoom. So you can go onto our live stream, you can rotate it, you can zoom in, you can essentially move it in any way you want. And that is specific to the user. So if you do that in your user profile or in your account when you log in, it won't impact how somebody else can log in and do it, because it's virtual, similar to how kind of multicast works. You can kind of have multiple users leveraging it at the same time, and it won't impact each other. And doing that also doesn't impact the detection operations or the data collection. So we leverage multiple streams in the sense that the camera is a fixed camera still doing detection and data collection, while you can on a separate stream rotate around, look at the environment, see what's happening, and do observational studies. So it's very robust in that sense.
Yeah, we call it a virtual pan, tilt, zoom, because it has all the functionality of pan, tilt, zoom without actually motorizing the lens and requiring you to do so. So it's pretty convenient and quick way to do that. A question here, probably more for Chris. When people look at buying new technologies, sometimes that means buying in a new way. So capital expenditures versus operational expenditures and cost or software with an ongoing fee. How have you approached buying a solution like this and the different ways that you need to account and budget for it?
I think it, depending on sort of where your community stands relative to the tolerance for, extra congestion. And obviously COVID has thrown a total wrench into all of that. It's reduced congestion, but, I don't think anyone feels confident that we're not going to be dealing with these issues moving forward, right? I think when you have the expense to keep the platform going, it's a very much a justified and understandable expense on a city council level to say, hey, look, we made investments to make traffic run more smoothly in our community, and this is not, early 2000s. In order to make these features of it beneficial for us moving forward, and they are beneficial, you have to kind of make the case, but I think it's a good and easy case to make that this is a worthwhile expenditure to make. So we did do the initial purchase with capital funds, but what we have found, depending on where you're at in the fiscal year, adding 1 or 2 or 3 at a time, especially if you get any mitigation funds from a developer or whatever the case may be, very, very easy and very easy to do that.
Perfect. And maybe another one here, Chris, for you, which is how do you communicate out results? So you mentioned that this is an initiative that Quincy really cares about. Citizens are concerned about traffic. How do you get the word out that you're doing things differently, or that traffic's different, or your kind of results of what you've done so far to the public?
That's a great question, and I would say it's one that we certainly could probably think a little bit more outside the box on with the tools that are at our disposal. The travel time module that's in Miovision is something that could, in theory, be communicated to people. We haven't chosen to do that, but we certainly could. But all those tools exist. I'd say we try to do, publicity when we do an installation, but in terms of ongoing interaction, the opportunity is there and the tools are there. So it's not as if you have to just guess. You do have some objective data that you can communicate to everybody.
Very good. Okay, I think that's all the questions that we had here today. Brent, unless there's anything that you would like to bring up, or any questions that you'd have, I'll maybe give the chat a few more seconds here to get any last questions in. But yeah, Brent, I'm not sure if there's anything that you want to touch on before we wrap up today.
No, I think we covered a pretty good range of use cases, and there's many more behind this and many other stories we could probably talk about. One thing that we can offer is if anybody wants to know more information, or they want to see more resources, we have a lot at our disposal, and we can also do some one-on-one sessions if needed. So I don't know, if you're interested, reach out. We're happy to keep talking about various topics.
And I'm happy my contact information is there. I'd be happy to talk about how we've kind of done things on the municipal level too.
Perfect. Well, maybe we'll wrap it up there. So a big thank you, Chris and Brent, for joining us today. We know you're busy and you've got lots of problems to solve, so we appreciate you taking the time.
Thank you.
For us, we really do appreciate it.
Happy to.
For our attendees, we will be having a recording of this sent out, so feel free to watch any parts that you want to see again, or forward it to any colleagues or friends that you'd want to see the content. So that will be online, and that will come to your email. And thank you very much for taking the time out of your day to listen to our speakers here today, to hear about the technology, and to see a little bit more about what problems cities are solving using this new technology. Of course, like as Brent said, and as Chris said, if with any questions or anything that you want to talk to us about, we're always here. Drop us a line. We'd love to talk to you about either your initiatives or how we can help you achieve some of your smart city and traffic related goals. So with that, we'll wrap it up. Thanks again to our speakers. Have a great day, and we'll see you at our next webinar.